In this problem, we need to find tangent of arc cosine of negative 2/3, and then in general, tangent of arc cosine of x, expressing the answer without any trigonometric functions. As is usually the case, the unit circle will be of great help. And actually the problem is asking us to draw the elements of this expression in the unit circle. So where is negative 2/3? Let's say somewhere here. Where is arc cosine of negative 2/3? Remember, arc cosine arc cosine of negative 2/3 is the unique angle or the unique number that is first between the boundaries 0 and pi, and second, the cosine of that angle is negative 2/3. So we get a point in the second quadrant. That is arc cosine of negative 2/3. And now it's easy to get tangent of that. So this here is tangent of arc cosine of negative 2/3. So how do we find it? Well, we can utilize, as always, similar triangles. Let's introduce some notation. O, A, B, C, and D. So clearly we have triangles OAB similar to triangle OCD, implying, for instance, that CD divided by OC equals AB divided by OB, which means that what is the length of the segment CD? Well, length of the segment CD is the absolute value of this number, because this number is negative, as we see from the picture. The length of CD will be negative. Tangent of arc will be negative. Tangent of arc cosine of negative 2/3. One more time. Distance CD is the length of this segment. Tangent here is negative. So negative tangent will be positive, and that'll be exactly that distance. OC, of course, is 1, because that's a unit circle. AB here is sine of arc cosine of negative 2/3. In general, the coordinates of this point are sine of arc cosine of negative 2/3, comma negative 2/3, vice versa. The y coordinate, of course, is sine. The x coordinate is negative 2/3. So AB is sine of arc cosine of negative 2/3. Know that sine is positive because it's the second quadrant over OB. Distance OB is 2/3 because this coordinate is negative 2/3. So this distance is 2/3. So from here, tangent of arc cosine of negative 2/3 equals negative 3/2 of sine of arc cosine of negative 2/3. And what's left to do is find sine of this arc cosine. For this, of course, we use Pythagorean identity. Remember that sine is plus minus square root of 1 minus cosine squared. And we see that because arc cosine belongs to 0 pi, where sine is positive, we take the positive sign here, and so this becomes negative 3/2 times positive square root of 1 minus cosine of arc cosine of negative 2/3 is negative 2/3. Let's not skip steps. So it'll be cosine of arc cosine of negative 2/3 squared cosine of arc cosine of anything whenever it's defined is the argument, so we get negative 2/3 squared. So that'll be 1 minus 4 over 9. So that's 9 over 9 minus 4 over 9, that's 5 over 9. And that is root 5, negative root 5 over 2. All right. Now, the second part of the problem is even easier. When we want to express tangent of arc cosine x, it simply is, by definition of tangent, sine over cosine. That was simply definition of tangent. Now, cosine of arc cosine is always the argument, so we simply get x. For sine, we get plus minus square root of 1 minus cosine squared of the argument. That is the Pythagorean identity. Sine squared x plus cosine squared x equals 1. From here, sine equals plus minus root 1 minus cosine squared. Now, because arc cosine is always between 0 and pi, so we're in quadrant 1 or quadrant 2, either way sine is positive, so we take the positive sign. Again, the explanation is that arc cosine x belongs to 0 pi for any x between negative 1 and 1. So sine of arc cosine of x will be non-negative. So, of course, cosine of arc cosine of x is just x. So we get 1 minus x squared over x. And note that this is true for any x between negative 1 and 1, except, of course, 0. Right, don't forget that arc cosine is only defined, arc sine and arc cosine both are defined only for x's between negative 1 and 1. And so this problem is now over.